Rational exponents just mean exponents that are fractions. So how do you make sense of something like 2 to the power of a half? Now, just as when I introduced zero and negative exponents, an exponent of a half doesn't make any sense from the point of view of explaining an exponent as shorthand notation for repeated multiplication. How do you multiply something by itself a half a time? But we have all these laws, and I've put down 2 of the exponent laws on the right. And if we want them to be consistent, we've got to come up with a meaning for 2 to the power of a half that fits the laws. So what if we took 2 to the power of a half and multiplied it by 2 to the power of a half? The same thing. I mean, another way of writing that would just be taking 2 to the power of a half and squaring it. So we can apply either of the laws on the right. In the first case, we have the same base, so we can just add the exponents. A half plus a half. But a half plus a half is just 1, and 2 to the power 1 is 2. Similarly, if we have an exponent raised to another exponent, we can just multiply the exponents. 2 to the power of a half times 2 is 2 to the power of 1, which again is 2. So let's think about this for a second. We've got something that we don't really know what to do with 2 to the power of a half, but when we square it, or multiply it by itself, we get 2. Well, we already know something that works that way. Root 2 times root 2 is equal to 2, or equally, root 2 squared is equal to 2. So therefore, 2 to the power of a half is exactly the same as root 2. And this is a link that establishes the fact that we have 2 completely different systems that do exactly the same thing. We really could get rid of one system or the other and be perfectly fine. In other words, we could do entirely without radical signs and just work with exponents. Or alternatively, we could get rid of exponents and just work with radical signs. However, for historical reasons, some things are much more commonly done using radicals, some things are much more commonly done using exponents, and so it's like having metric and imperial. You're stuck with them both, you've got to be able to flip back and forth between them. So let's see some other fractions as exponents. How about a fraction, a third? So 5 to the power of 1/3. We can do exactly the same thing that we did above to figure out what 5 to the power of 1/3 really means. I can either multiply 5 to the power of 1/3 by 5 to the power of 1/3 by 5 to the power of 1/3, or I can think of taking 5 to the power of 1/3 and cubing it, and following those laws of exponents I've got written in the upper right hand corner, I end up with, in the first case, a third plus a third plus a third, which is just 1, or a third times 3, which is 1. Either case I end up with 5. So in one case I'm multiplying something by itself a couple of times. In the other case I'm cubing it. In either case we already know something that works like this, the cube root. So an index of 3, cube root of 5, is therefore the same as 5 to the power of 1/3. And here's the link. It's not quite as obvious because we don't put the index in, but remember, when there's no index written, there's an index of 2 implied. So if we have a base to the power of 1 over m, that m is the index on the radical. And this is the rule that links any rational exponent with any radical. So if the exponent is a half, that means you're taking the square root of it. If the exponent is a third, that means you're taking the cube root of it. And we can go further. If your exponent is a quarter, that means you're taking the 4th root. If your exponent is a 10th, you're taking the 10th root. Now the only complicating factor here is, what do we do if the numerator is something other than 1? Like, let's say, 3 over 2 here. 9 to the power of 3 over 2. Well, there's 2 ways to handle this. One way is to break the exponent into 2 pieces, a half and a third. Actually, we're going to do that for both ways. But we can think of 3 over 2 as 1/2 times 3. So we can write this as 9 to the power of 1/2 to the power of 3. We're used to using that rule going in the opposite direction, but certainly if you had 9 to the power of 1/2 raised to the power of 3, you could just multiply those exponents to get 9 to the power of 3 over 2. Alternatively, we could write this as 9 to the power of 3 raised to the power of 1/2. Now they're both equivalent, but one's going to be a lot easier to deal with. You're probably, if you encounter something like this, going to be working without a calculator. So you know the numbers are going to work out nicely. It's just a question of how quickly you can get there. Now, 9 to the power of 1/2 just means take the square root of 9, the second root of 9. So 9 to the power of 1/2, that's easy. Square root of 9 is 3. And so we have 3 inside the brackets, and we're cubing that. 3 cubed is 3 times 3 times 3, which is 27. Now we're going to get the same thing on the bottom example. The trouble is, we've got to cube 9. We've got this huge number. 9 times 9 times 9 is a very big number. 9 times 9 is 81, times 9 again is 729. And then we're going to be taking 729 and raising it to the power of 1/2, meaning taking the square root of 729. This is not easily done in your head, and so in general you do not want to proceed this way, even though it yields the exact same result. So 729 raised to the 1/2 gives you 27, but I would say stay away from doing this. Try to keep the numbers as small as possible, and that way you'll get the answer much more quickly.